my screen. Okay, Bismillah ar-Rahman ar-Rahim. So the recording has started. So let me share my entire screen. All right. So hopefully very soon you'll be able to see my screen. Yes. All right. So today we're going to be talking about the course, which is Discrete Structures 1. And before going into these details, inshallah, all these I'm going to upload all what I have here. I'm also going to upload some slides that I have from previous faculty members that taught the course. I'm going to I just went through just the first one, which is for this week, and I added some things, made some additions, corrections, updates. I did not do that for the rest, but it's most likely it's very minor changes, so I'm just going to share everything with you. So you'll have everything, inshallah. By everything I mean the slides. You're also supposed to have the book. I hope you do. I have an online version of it. Yeah, so this is for me. Unfortunately, I cannot share it with you because this is I don't know. There's some kind of copyright issues with that. I need to check if they have some kind of online version that you can have access to, you as a student. I have no idea, honestly. When they close this library, I have no idea what's the way now. Probably you have to buy it or something. Anyways, so everything, all the slides are basically taken from this book. So is the book something optional that you could get? No, it's not. It's better that you have it. And the good thing is that you're going to use the book for both this course and the Discrete Structures 2 as well. So it's not something that you're going just to buy for one semester and then you'll have to sell it. So it's a big book, but it's going to be used in 2 courses. So before I start digging into the content of the book and etc., what is the purpose of this course, etc., I would like to give you a general idea about how to get a good grade in the course. So if you have any I cannot just there's some people writing things. So if you want to do something, I don't know if you can raise your hand. If you raise your hand, I'll just like to know if I'm hearing some notification of some kind. Can somebody raise his hands, please? Just click on this. Okay, good. So if you want to talk, just do that, okay? So that's why even if I'm not watching here, I'm somewhere else, just if you have a question, just raise your hand, and this is how, inshallah, we're going to be notified, because I can hear a notification sound that tells me that somebody has raised his hand. So let's get into the most important part of this lecture, which is how to get a good grade in this course. Now, my advice applies specifically to this course because I'm going to give examples for this course, but this advice that I'm going to tell you actually apply to any course. So there are 3 steps, easy steps. They're very easy to do to get an A and A plus bi'idhnillah. However, even though they're easy, not everybody is able to do them because they require discipline. And I'll elaborate more, inshallah. The things that actually the steps, there are 3 steps. The first step is the initial one, is that before we meet in the class, normally, well, this first meeting is not counted because it's normally they just enabled a Blackboard, so it was not available to you before. So yeah, it's not going to be counted. But the following weeks, before inshallah today, and most likely today and tomorrow, I will just also update the course, the Blackboard course. So this over here is going to be much, this over here, I'm just going to make some changes to those and organize them a little bit differently. So you'll have somewhere here all the data that I showed you, all the files, the slides. If I can share the book, I'll do that as well, the course semester plan. You'll have all that. And the plan actually is this something we're going to try to follow as much as possible, as close as possible. So this is the plan for the semester. We'll get back to that, inshallah. But what is this first step? The first step is that you know before the class, let's say next week, you know what is going to come your way. This is what we're going to be talking about. You have the slides, you hopefully have the book, either the online copy or the physical one, and all you need to do is to have an idea about what's going to be part of these sections of the chapter 1, section 1.3 and 1.4. What are they about? I want you to have an idea. Now, what's that idea? The idea means if you can find some videos, recordings, you can just look at them, but just you can speed it up. I don't want you to understand exactly everything, but I want you to have an idea about what are the parts that seems to be easy to understand and the parts that maybe requires more time, or it's actually more challenging. Now, why is that important to do? Now, this task is taking maybe half an hour, and you can do that by listening to some videos, for example, or looking at the slides quickly, or maybe looking at the book, some sections, etc. So it's not going to take a long time, but it's a very crucial step because it enables you to have an idea which parts are actually requires your 100% focus. Because the step number 2 is actually based on that. When we're going to be meeting, like today, we have a almost 3 hours long meeting. Are you going to have your attention 100% all the time? Well, even in the classroom, that's hard to do. It's actually almost impossible. We are imagine during Salah, the prayers. It's very short, 5, 7, 10 minutes. And it's impossible not to just go astray with your thinking. So the idea is your focus in the lecture, regardless if it's in class, in person, or online. Online is even worse because you might be doing something else that I have no idea what you're doing, but you might be listening to me and then doing something else. So your attention maybe it's not going to be 100% all the time. That's for sure. It's not going to be 100% all the time. So when you know the parts that are easy, the parts that are less easy, let's say, you know what time, or if you hear some words that you spotted before the class that, this thing was not easy for me to understand, you know that you have to switch your focus 100% on. You switch on your focus to 100% and make sure that you try to understand every single thing that I will be talking about. And then if something is not clear, you're going to be having to ask questions. And this is the step number 2. So the step number 1, before the class, you have an idea, and so you can manage your focus during the class. And during that class, if something is not clear, even if you need a confirmation, you just ask a question. Now, this step number 2 is very crucial. And this is where many students actually fail to be consistent in it. So for many reasons, maybe I can try to talk about some. I don't want to spend too much time talking about that, but just I may give some reasons. So, but first of all, why asking question is the most important part? Because my job, I'm being paid to answer your questions. Because whatever I'm telling you, I'm not giving you any secrets. Some information that only I have. This information that I'm going to give you, it's actually from a book that somebody or many people actually made and compiled. And you have other sources of information. You have YouTube videos in different languages, whatever. So the information that I'm giving you is not something that I have the only access to. So then why you come and listen to me? Well, maybe alhamdulillah, because there's a good reason. You have the attendance thing, because alhamdulillah also you're getting paid to be here, alhamdulillah, most of you, if not all of you. So this is a blessing that the government is investing in you. That's why actually we have to take attendance, because that's the only reason why we take attendance. And in other universities who people are paying to study, you want to come, you're welcome. You don't want to come, you're welcome. And this is your money. You spend it the way you want to spend it. So the idea is, the main job for me to be here with you is to answer your questions. So you have to ask a lot of questions. And historically speaking, I've been teaching many different courses, and at the end of the semester, when I see the grades of students, and on the top of the list, always I remember those who were asking a lot of questions. They always end up in the top of the list. And you ask questions for many reasons, but the main reasons one you need to have to ask a question is that, and maybe this can be one of the reasons why some students might think why they're not asking questions. The main reason why you should ask a question is that that's the best way to learn. Because Allah Azza wa Jal says, فَاسْأَلُوا أَهْلَ الذِّكْرِ إِن كُنتُمْ لَا تَعْلَمُونَ. فَاسْأَلُوا, that means you have to ask if you don't know. If you don't know, then you have to ask. It's not like an optional thing to do. It's a must. You must ask. You have to ask if you don't know. فَاسْأَلُوا أَهْلَ الذِّكْرِ إِن كُنتُمْ لَا تَعْلَمُونَ. So that's the most important reason. The other thing is that there are people that have many learning styles. I mean, let me just maybe go for that. Learning styles. So maybe different learning styles. So let's have a look. So there are different ways how people learn. If you have never heard about that, you can just, there's some free tests that you can try online that tells you, okay, what is your strongest learning style. So each one of us learn based on all these styles, fine, we can be fine. But the idea that some styles are actually more easy for us than others. So, okay, let's have a look. So some need to learn by seeing some charts, graphs, pictures. This is actually the best way for them to understand something. If you don't draw something, it's going to be hard. But this might, for some, be confusing. Actually, it's too many details. Okay, basically, explain it first. So tell me, what is it about? We need to talk about it, and then something, and then I'm going to be able to understand it better. I mean, this is also simplistic. There might be some other styles. These are like maybe some of the main ones. Some are actually, they have to read it and write about it. Then they'll be able to, if they read it or write something, then they can be able to understand it more. That's why some of you, maybe, if this is your learning style, you find yourself taking notes a lot as a way for you to understand. Another thing is this kinesthetic, which is this learning by doing. If you don't tell me actually, this is something else. I mean, this is maybe if some hands-on something, you have to learn something practical, you want to see it, to do it actually to be able to learn it. But these are like some examples. There are others that actually, if you don't tell me, okay, what's the application of what you try to explain to me, if I don't know how it is, where am I going to need it, it's going to be much harder for me to understand it. So tell me where I'm going to need, then explain it to me in different ways. So my point here is there are different ways how to learn. While I'm explaining something, one of these topics that I'm going to be explaining, or one of these parts, I'm not going to be using all different styles at the same time. So I'm going to use in some. So of course, maybe I'm not using for some their best or their strongest learning style. That's why my message might not be formatted in a way that is the best for those people. So then something might be not clear. So you have to ask a question about it. And this is something that I want to talk about it, because one of the main reasons students sometimes tell me they don't want to ask questions. First of all, they say, oh, I don't want to disturb you. And some of they think that, oh, maybe if I ask a lot of questions, I'm going to be disturbing also the class. The students are going to tell, oh, you know, the teacher maybe is going to be disappointed because someone is stopping them from talking, and then they have to answer those questions. Or some students, they can say, oh, this guy is actually always disturbing with questions, or this person is always disturbing with questions. So that's why I want to make sure that everybody understands that people must ask questions, because that's the way we interact with each other, is that we use some learning styles that might be not the best or the strongest for you. The other thing is that sometimes you just would like to ask questions just to confirm that you understood it properly. And to those who think that they disturb me actually by asking questions, Actually, it's actually the opposite, because when you ask a question, maybe because obviously I'm not someone who is going to be perfect. That means my explanation is going to be the perfect one that has no shortcomings. Everything is clearly explained without any mistakes, even. So, no, I might make some mistakes. I might explain something in a poor way or not the best way. So, asking a question might help actually yourself to understand, might help me correct myself, or maybe realize that I forgot to mention some things, and also help others. So by asking questions, you understand that you get hasanat as well, because you helped others also understand. So you were the reason why they also understand. So, anyways, asking a question is the way to learn. Asking a question is normal because we have different learning styles. So you have to ask questions if you don't understand something. And not even that. Sometimes you might ask a question and I answer it, but even my answer is still not clear. Because when you ask me a question, I'm going to try to change the way I'm explaining. So I'm going to try to change the learning style to try to see, okay, maybe this is not the number one learning style, maybe this learning style number two. But maybe your learning style is the one number three. So maybe I use number two to explain the learning style number two is not yours. Still, it's not going to be your best learning style. So even if I'm explaining and it's not clear, I'm expecting you to tell me, sorry, teacher, but this is still not clear. Can you please clarify it more? And another thing is that another reason why some students might not ask questions is because of the English language. They feel that, maybe if I speak, my accent is not good, or my English is not good, maybe I'm not going to use the correct words, and maybe this is why I'm not going to ask a question. Well, to those people, I say, first of all, this is not an English class. So if you make a mistake, that's fine. We're here to learn. That's why we make mistakes, to learn. This is part of the learning curve. We make mistakes. Now, making a mistake in the language, that's not the point here, because we're not learning how to speak. We're using that language just as a tool. So anyways, not to spend too much time on this. Step number one, have an idea. What we're going to be talking about during the class, so you can manage your attention. Step number two, you ask a lot of questions. If you don't know what to ask, just tell me, especially now online, you can just tell me, please, can you go back to this slide, for example, to this part? Can you explain this one again, please? This first line, this second line, so you don't need a lot of English, just to point me to a direction to somewhere that is bothering you. So ask a lot of questions, as much as you can. And the more questions you ask, the better you're going to be. And if you do that, now think about it. You had an idea about the topic. So you've seen the topics that we're covering in a week. Then during the class, you paid attention. So you know the parts that had to require your full attention, and you were present. Your mind was present during those times and paying attention. And if something is not clear, you ask a question about it. At the end of the lecture, you should get out of the lecture being understanding the topics. So your review time, when time comes for the test, for example, like quizzes or midterms, etc., is going to be minimal, because you already know the topic, because you were paying attention, you're asking questions when something is not clear. So you just need maybe a little bit of review to be able to be up to date. So step number one, before the class. Step number two, during the class. Step number three is after the class. So after the class, what do you do? Well, basically, during the class, we're going to do some exercises. And I'm going to give you also some exercise to do after the class. What you have to do is to make sure that the exercise that we do during the class, you're able to do them again without looking at the solution and get it right. So we do something, you're able to do them, no problems, that's great. That means this exercise is done. You don't have to do it again. But if for some reason you try to do an exercise that we did together, and then you end up having a different answer than the one that we had, or the solution of the exercise is different from yours, then you just go back to the solution, because everything is provided again. You look at it, you understand it, and then you do the exercise again. You don't assume that the exercise is done just because you read or had a look at the exercise solution and said, khalas, I understand now. Well, if you understand now, okay, test yourself. Do the exercise again and see if you can get the same result. And these are the three steps. Now, if you see this, if you try to put some time on how long it would take for all these steps to be done, well, step number one is before the class. Step number two is during the class. So during the class, you're here already, so I don't count that time. So before the class, maybe half an hour, 45 minutes maybe for some long times, whatever. After the class, maybe 45 minutes, an hour, depending on how many exercises we did in a week. Maybe, let's say, maximum 2 hours. So 2 hours after the class, 1 hour after the class. So that means 3 hours in a week for this course or for any course. This is how much it takes to be, I mean, the minimum that you can do to have an A+. All you have to do is, before the class, have an idea. During the class, you ask a lot of questions. And after the class, you just redo the exercises. So if it's so easy, why not many people have the A+ or the A+? Because you have to do that every single time. And this is where many people fail. They might be doing that one day or 1 week or 2 weeks, but then something happens. They had to do something outside. Okay, you're a little bit tired today. I'm going to do it tomorrow. And this is where things become sloppy. So if you think about it, you just need 3 hours per course. So if you have 3 courses, 4 courses, let's say that means 12 hours for 4 courses per week. And we're talking about a week, or maybe more or less, something like that. So it's not really that much. You still have time to relax, you have time to eat well, sleep well, and exercise, etc. And have some family time, friends time. The only problem is that if you don't do that consistently, then this is where you lose. And if you do that consistently, that's where the A+ is going to be much easier to reach, because you know the topics. Why won't you be able to get a good grade? So that's my 3 steps that I suggest you just try to follow as much as possible. And the first time, if you're not used to this method, it's going to be taking you maybe a little bit more time. But then the more you do it, the more efficient you will become, and it will be much easier for you. All right, so this being said, if you have any questions, please just raise your hand so I can know this is you want to talk, so I can have an idea what's going on. So ask a lot of questions. That's what you need to do today, right now. And then after the class, you'll have to redo the exercises. And then for next week, before the class of next week, you should have a look at these. Now, let's talk about the topics now. The topics that we're going to be covering are these ones, and in this order. Also, what I have included here is that the assignments, assignment 1, assignment 2, they are not going to be outside of the class. They are going to be in the class. I mean technically in the class. I'm going to give you some kind of mini tests. Each one of them like 2%. So these mini tests are going to take maybe 5 minutes. It's very short. So at the end of the lecture, in the middle of the lecture, it depends. So I'm just going to put that somewhere depending on how what the content. I'm just going to decide about it later, inshallah. But the idea is, I want to give the opportunity to get the marks. These are going to be very easy and multiple choice questions. They're going to be graded automatically, so you're going to be able to get that. And I'm going to prepare a pool of questions with the help of GPTs or whatever. And by the way, talking about those, I'm not against you at all using GPTs. Actually, this ChatGPT, Gemini, whatever you're using. However, my problem is, don't use them without, like, to switch off your brain and then just use them blindly. First of all, they make a lot of mistakes. Second, they are very helpful, so you need to learn how to use them. You have to send the correct prompt, etc. And third, I'm against them if you're using them to solve like the quizzes and the mini tests. Okay. We'll talk about the quizzes later, but for the mini tests, they're going to be online. But the quizzes, they're going to be in class. okay, when is in class? I mean, we're not going to be doing them at 9, 10, 11, like this timing, but it's going to be on Tuesday, but 4, 5, during this period 4, 5. It's going to be 4, most likely, not 5, but during period 4. The location is going to be organized later, inshallah. So it's going to be in the lab. It's going to be online in the lab, but it's going to be proctored. So it's not going to be something that you can do outside, because we don't have any way to confirm that it's you who's doing it first, and then also that you're not using some tools to be able to do that. So anyways, these mini tests, if you count them, actually maybe you can see them here better. These mini tests, 2 each, are going to be the mark for assignment number 1, and the assignment number 2, another 5. Each one of them 2, 2, 2, 2, 2, and I put them 2 only, just maybe if someone is absent, so it's not going to be a very big impact. But try not to be absent, because that's my incentive to you to not be absent. Okay, the first week I didn't do that because I was not sure that actually we're going to be having a class. And on top of that, even if you have the class, this is the first time. I don't want to surprise you with that. So, but we have these, and you can see we have like mini tests chapter week 2, week 3. Then week 4, this is when we're going to be having the quiz 1, which is going to be period 4 on Tuesday. The location, I'm going to announce it later, inshallah, once we organize. Once I have it. Then we have week 5, we have the national day. It's going to be on Tuesday. So unfortunately, no class on that week. So it's like we lose a week. But week 6 and 7, again, we're going to be having mini tests. And then the week 8, this is where the midterm theory is going to be. It's going to be 1.5 hours. And week 9, mini test again, 10 and 11. Week 12, this is where we're going to be having the quiz 2, again, period 4. And then there's the 13 and week 13, and then there's the winter break between 13 and 14. And then we have 14 and 16, 14, 15. This is also a mini test. And then we have week 16, which is also teaching week. So in that teaching week, I don't know how this is going to be. Is it going to be like a review, or if we missed something because of this national day, or so if we're able to cover everything, which normally we should, this is going to be most likely a review on week 16, because the exam is scheduled to be on week 17, inshallah, the final exam. And so it's going to be most likely a review. We're going to review of everything from the beginning till the end. But as you can see, you have actually pretty much every week, starting from next week, you have an assessment. Either it's a mini test or a quiz, and so on. So it's going to be up until the end. Any questions? So far so good? Yep.
Is there a textbook for the course?
A textbook? What do you mean by textbook?
Like the book.
The book? Yeah, there is a book.
The source.
Yeah, I was talking
Can
about.
I see the name so I can read it?
I'm going to give you that. I mean, I'm going to share this with you. Maybe let me do it right now. This is this file. I'm just going to try to find a way where to put it. Course objective, maybe course content. I'm going to put it here, maybe somewhere. I'm just going to review that. I'm going to change that thing. But let me say, I'm just going to put it here. Oh, this is too many things. Okay, I'm not going to put it here. Course review, delete. So maybe course content, yeah, somewhere here. So I'm going to rename that course content, but for now, this is, let's say this is going to be edit. Course plan. So now you can, I'm going to have a file. Let me add that file, let me browse, and I think it's somewhere here. Alright, so this is, why this is not the name? Normally it should show the name. Open in browser, that's fine, submit. Okay, so you should be able to see it now in this course plan. So you click on it, you'll be able to see that this is the file, and this is the file, this one. So this is the name of the book. and it's 8th edition McGraw Hill.
Thank you.
You're welcome. Any other questions about the plan? So, again, I really advise you to try to get an A+, because first of all, it's not hard, and won't you have an A+, why others have? It's not like you have like not the ability to do it. Bismillah, all of you, alhamdulillah, right now you should have realized that whatever you want to do, you'll be able to do it. You have the capability to do it, bismillah. So why not have the A+? And I just thought about something also, that many students, sometimes they come to me and I hear them saying that, oh, I want to graduate early. I just would like to give you some thoughts about that, because I think it's really a mistake if you just focus on graduating early, because at some point you're just becoming a little bit impatient. Oh, it's so many semesters, I want to finish as soon as possible because I want to move on. Well, good for you if you move on, but if your GPA is less than 3 or 3 point something, I mean, what's the point of moving on and then ending up with a bad GPA? If it's less than 3, that's actually, it's really not a good idea to try to speed up. If it's less than 3, you should take the minimum number of courses that you can. If you don't care about the allowance, the money that they give you, take 2 courses. That will be enough. Just make sure to get the A+ on these 2. So if the allowance is important to you, there's no way you can live without it, then okay, take 12 credits. That's the maximum you can take, so take those 12. My point here is, if you are an entrepreneur, let's say you're a CEO of a company, that's your company you just built, and then you have an open position, you need one new employee to hire. So you make an announcement and then you have 100 people, let's say 20 people, 10 people, 30 people, whatever the number is. Are you going to meet with all of them? As a CEO, I'm guessing, very busy. And you all guess that, okay, you don't have time to meet with 20 people, even if this is just as 20 or maybe 10 people, and you need only one. Why are you going to meet with 10 of them? We have to sort them, maybe filter out some of them. So what's the criteria that you're going to use to filter those people, those candidates that you have, the files that they gave you? You're not going to filter those that actually finished late, or maybe they graduated 1 year later than the others. You're not going to do that, because a better indicator would be the GPA, because the GPA means that many good grades in the transcript. So that's what people are going to do. The first thing they're going to do is to sort all candidates based on their GPA. And this is what you're going to do if you were the boss. So the GPA is what's more important. So trying to graduate early is not really something that is that important. If you have like 1 year, additional 1 year to graduation, like the minimum people have 4, you have 5, and then your GPA is 3.5, and someone had just graduated in 4 years and his GPA is 2.5, well, which one they're going to try to talk to first? I'm pretty sure you will not be talking, if you were the one who will be hiring, you'll not be talking to the 2.5, because you will start talking about with the 3.5 first. That's the thing. So try to be the person who focus on having a good GPA. And to get a good GPA, there is no secret. You have to have good grades. And to have a good grades, I'm just proposing and suggesting a way for you to get that, inshallah, bi'idhnillah. Just, you have to be consistent. And that's what makes the difference between those who get the A+ and those who don't. It's not that they have a bigger brain than you. It's not that they have, like, they study 24 hours, 7. No, they just have a normal life. Sometimes if you know someone who consistently has an A+, you'll see that they don't study that much, actually. So the difference between them and you is what? Well, during the class, they pay attention and they ask a question. And maybe if they don't ask a question, that means maybe before the class, they spend more time in this step number 1 trying to actually learn on their own. So instead of taking just 1 hour, they take 2 and spend 2 hours to try to understand on their own. And then a small percentage is what is left for the class. Anyways, my point is, you have to decide, take a decision. This is your life. Nobody's going to force you to do whatever you don't want to do. So you have to decide that you want to do that. And I suggest you do, because it's not very hard to get that A plus. And I'm saying A plus because if you aim for the A plus, if for la qadra you some accident happens, etc., you have some issues, the worst case scenario can fall into an A or a B plus. So this is still not bad, but it's much better if you're aiming for a C, and then if there's an accident you reach a D plus or a D, or la qadar Allah an F. So that's my suggestion. It's easy to get, just do it. But again, this is my suggestion. You're the boss. You decide what you want to do. So I think I made the point clear, inshallah, hopefully. I wish you that, inshallah, you're going to be the one that gets those A pluses. And by the way, talking about that, as you can see here, all these things are going to be, even the midterm, unfortunately, midterm theory and midterm and final theory, these are the ones that are going to be on paper. Everything else is going to be on Blackboard, which means they're going to be graded automatically. It's not going to always be multiple choice. Sometimes you have multiple options. Something you have to choose more than one option, or maybe you have to type something or write something and upload the file, whatever. So it depends on the weeks and the things that we can do. But the idea is that I'm not going to ask you some tricky questions. So it's basically what we do. I'm not the type of person who is going to try to trick you into see if you fall. I'm digging a hole and see if you're going to fall in it and say, haha, yeah, I got you. No. Whatever we see in the class is what I'm going to ask you about. There's nothing like more that I'm going to do. So basically, if you study those things, you're going to be good and get the full mark. And I'm not the type of person who thinks, if I give you full mark, how much am I going to give myself of that? Some people might say. I'm not one of those. If you get it right, you get 100%. That's it. And you can get 100% for sure, inshallah. Especially on this mini test, because they're especially very easy. All right. Okay. So this being said, let's start with our first topic, which are this propositional logic. Again, if you have any question, just raise the hand so I can see it and I can stop and ask it. So these files are done by Dr. Abdul Salam, who left, retired from the college. Yes, please.
Doctor, can you upload the slides, please?
Yes, I mentioned I will upload all of those slides, inshallah. I'm just finishing the lecture, then I'm going to upload all the slides. And I mentioned that also, maybe not everyone got that. I just finalized this one, maybe this one as well. I finished it as well, but I'm going to upload everything, and I might later on add some more changes, and then as soon as I make a change, I'm going to upload it again. And but I'm going to give you all what I have. It's just that I did not check all of them yet. This is from Dr. Abdul Salam, so I don't know if they are all covering what is expected to be covering. I think so, but I noticed that in some cases some small parts were missing from whatever, for example, in the book. Let's say for this here, this is the chapter 1. Where is it? Okay, here. For example, see, this part was not in the original. Okay, where is this part, for example, was not part of that. So I'll just include a slide or two just to talk about it quickly, briefly. So I'm going to right now I'm just going to give you everything, and then slowly I'm just going to review everything and make sure that it's going to be matching whatever we are expecting to do. Yeah. So let's talk about this propositional logic, and basically the idea about this, what is discrete structures. I'm just going to skip those talking, etc. But the idea is, why do you need to talk about this discrete math? Discrete structures is basically discrete math. It's some like basic mathematical rules that we're going to be talking about. And most of you, you did some programming, so you've seen some Boolean expressions, for example, and this is something you're going to be relating to that here. But the idea is that there's a lot of things that is going on. Let me see if I can just have some kind of pen. There are a lot of things that actually. Let me try to use this. All right. Okay. That we're going to use that requires some kind of logic. Yes. Go ahead. Yes, Lema? Something happened? Okay, she may join later. Okay, so there's some kind of mathematical reasoning as well. So these are some kind of basic things that actually are going to be required. I'm just trying to use my, okay, sometimes I don't see what it is. Okay, so this reasoning, and it has some kind of logic that I would like to, maybe I'm going to use my mouse, it's going to be easier. Okay, so they're going to also, some of these rules are going to help us design, back here, design some circuits, because especially for these Boolean things, it's like I have this AND and OR, and if you're going to do digital logic design, for example, you're going to see that some of these AND and OR and NOT, for example, if you did some programming, you've seen some of those, and these are going to be actually some components that can be found in some circuits. So there's a lot of things that are going on. So that's why this here provides some kind of general and theoretical background for those things. So let's talk now about these propositions. What are they? So a proposition is just a big name that says something that can be either true or false. Of course, it cannot be both. So that's what a proposition is. Now, if you look at here, and you can see that these are declarative statements, and which ones are propositions. Washington, D.C. is the capital of the United States. Well, it can be true or false. Yes, then this is a proposition. And actually, it's true. And Toronto is the capital of Canada. Well, if you don't know, this is not Toronto, the capital of Canada, so this is actually still a proposition, but its answer, this is false. So it's not because it's false we're going to say, oh, it's not a proposition. No, it is a proposition, but it's going to be false. What about this one? 1 plus 1 equal 2. Well, this is a proposition, and it's true. So it's a proposition and it's true. What about this? It's again another proposition. So these are all propositions, but some are true and some are false. What about those then? Well, these are not propositions. See now, what time is it? Is it a true or false? So you cannot answer with a true or false on that. So that means this is not going to be not a proposition. So this one is not a proposition. So not a proposition. What about read this carefully? Can it be true or false? No. So same thing. Not a proposition. What about this x plus 1 equal 2? Can it be true or false? Well, no, it can't. This is again not a proposition. But if I say x plus 1 equal 2, knowing that x is equal to 1, that changed the thing. So this becomes now a proposition, because 1 plus 1 equal 2, well, that's true. This becomes a proposition and it's true. And if I make it x equal 10, it's again a proposition, but it's false. But it's a proposition. It becomes a proposition. Now it's not a proposition because it is actually, it's not a proposition because it has this x, and then you cannot answer by true or false just by without having some more information about the x. And that's the idea behind those what is a proposition and what is not. So if there's some kind of propositions, generally we give them some kind of names. So for example, this can be this is not a proposition, so we cannot talk about it. But this, for example, this one, I can say assume that this proposition P is equal to this is thing, and this is proposition Q is this. And then I can mention, okay, P is true or false, or Q is true or false, and they start with P because of proposition, and then P, Q, R, S, and if you have many ones you'd like to use, this is what is going to happen, P, Q, R, S, and T, and then you keep going. And the truth value is either true or false. That's what is going to be the true value of a proposition. And then based on these, we can have some kind of propositional calculus and some propositional logic. And we're going to be doing some of that, inshallah. And the first operator that we're going to see, if we have like P to be a proposition, and let me just try to use this. If P is a proposition, I'm trying to find my cursor. Okay, it's here. So if P is a proposition, then the negation of P, it's referred to it as this thing, minus P. Sometimes also refer to it as like this one, or like a minus P, or like this tilde P. So all of these, they mean the same thing. It means the negation of P. What does the negation of P means? If P was true, if P is actually true, then not P is going to be false. So that's what it means. The opposite of. And if P is false, then not P is going to be true. So basically that's what it is. And so let's have a look here. Find the negation of the proposition Michael's PC runs Linux, and express this in a simple English. So this could be, I mean, we could have different ways how to do that. Sorry, different ways how to do that, but we can say Michael's PC does not run on Linux, like for example here, does not run on Linux. Or I can see it's not the case that Michael's PC runs on Linux. So we just different ways how to mention the same thing. What about this? Vandana's smartphone has at least 32 GB of memory. Same thing, the negation of it. It's not the case that you can just mention that this is sometimes the easiest way that you can just negate something without doing any change on the rest. So you can keep this part, which is this P. Let's say if this is our P. So this P is this sentence. And all you can do to make it not here, you just add this part here, add your P. So it's not the case that blah blah etc. what was mentioned. Like here, it's not the case that, and then you mentioned the exact same sentence. So that is the negation. Or you can do something that basically try to work with the meaning. So Vandana's smartphone does not have at least 32 GB. Does not, because it has at least 32 GB. You can say does not have at least 32 GB. Or you can say has less than 32 GB. Because if it does not have at least 32 GB, that means it has less than 32 GB. So whatever something is that equivalent, but the main idea is that I'm negating something. I'm doing the opposite of something. And then we can represent these in the truth table. I think most of you have seen this, right? So I don't have to spend too much time on those truth tables, correct? If you have any problems, you just stop me, all right? Because if you don't, that means I understand that you're happy with this. You've seen this before. So the truth table is basically a table where I mention like the proposition and then all the possibilities, the possible values that it can have. So a proposition can be true or false. So that means if I do this not P or the negation of P, if it was true, it will become false. If it was false, it will become true. So that's what it is. Okay, then we have another operator, which is the conjunction. Again, trying to find this here. Okay, this conjunction. And it's represented with this. And this is the equivalent of AND. P and Q. And this is going to be true when both P and Q are true. For everything else, it's going to be false. That's why when we draw the truth tables, we're going to now have two propositions. We have P and Q, and then this is the result of these two. So if P is true, Q is true, then P and Q is true. If P is true, Q is false, then it's going to be false. If one of them is false, or both of them are false, everything else is going to be false. It's going to be true only in one case, if it is both of them are true. And there's actually some kind of rule. The number of possible rows in a truth table is 2 to the power of n, where n is how many propositions do I have? How many propositional variables do I have? I have 2, that means I have 2 to the power of 2. This is equal to 2 times 2. Okay, something, which is 4. That's why I have here 1, 2, 3, 4. And we always start with true, the combination. This we prepare all the combination of these. True, 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 false, false, true, false, false. So we start with the true, and then for the other one we start. This is one stays at true, and then we do true, false, and then this one stays at false, and we do true, false again. And if we have 3, I think there's something about it. If we have 3, again same idea. We just true, 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 and then this one stays the same until we have a true, false here, and then we see you can have another true, false here, another true, false here, another true, false here. So we just fix true, 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 and then we make a combination. We always start like this. Basically, you don't have to always start like this, but this is the best way so you don't make mistakes. Now, because if you have 4 now, 4 propositions, now it's true, 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 false. It's becoming, if you try to make them not with the system, you're going to get confused and not get all the possibilities. So if we have like 4 propositions, how many rows do we have? 2 to the power of 4, which is 2 times 2 times 2 times 2, 4 times 4, 16. So you have 16 rows there. Okay, now this is an example of using the conjunction. Find the conjunction of the proposition P and Q, where P is Rebecca's PC has more than 16 GB free hard drive space, and Q is the proposition the processor in Rebecca's PC runs faster than 1 gigahertz. That means we have P and Q. So basically what we say is Rebecca's PC, the whole P is this. Rebecca's PC has more than 16 GB free hard drive, and the processor in Rebecca's PC runs faster than 1 GB. So this is basically it. And that's pretty much it. So I don't think this is something very challenging, but I'm just trying to lay out the rules, because later on it will become more interesting when we're going to do some combinations. And this is called some kind of composite propositions. We're going to have this and, or, not at the same time, and this is going to become more interesting. So let's have a look now. We said conjunction is the and. There's something called a disjunction. You need to just to be familiar with these names. Disjunction is the or. So you've seen the or before. So or is going to be true if one of them is true, it's going to be true. The rest is going to be true. If one of them is false, it's not going to matter. Unless both of them are false, then the result of this disjunction is going to become false. So that's the or. That's how the or works. And I think you're all familiar with that. The one maybe you're not familiar is the inclusive disjunction. It's kind of, even the name is a bit confusing, but actually it's this is called this inclusive because it includes. It's true if one of them is true, and it includes all the possibilities. So if one of them is true, it's true. But there's another one which is called the exclusive or exclusive disjunction, and it's denoted with this. It's an or, and also referred to XOR in some cases. What's the difference between an or and XOR? It's all the same, except that if both of them have the same, it gives you false. So the only difference is this here, this one here. It's like an or, but for the or, if you were using the normal or, the inclusive disjunction, you're going to get true or true gives you true. But if you do this, it's going to be only true if they're different, if one of them is different. That means I want this one or that one, not both of them. So if both of them are true or both of them are false, this XOR or this exclusive disjunction is going to be false. And that's the XOR. I want to just take a minute, make sure everybody is understanding. The main thing, and before I get the question, the main thing is that the difference between the OR and the XOR, if I'd like to maybe write this P or Q, the difference, this is going to be true, 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 and false. So basically the difference is this one. Yes. Khalid? Please go ahead. Maybe some problems with the microphone, or I cannot hear you. I see the microphone is activated, but
Is there a three-way or more in this junction?
three-way or more? What do you mean three-way or more?
So I can have PQR.
Yeah, of course. This is this.
so-
Yeah, we this is the composite that I was talking about. Yes, we will be having actually. Yes, but now right now we're just talking about the basics to understand the different operators that we have. So we've seen the let's see, we've seen the not, we've seen the and, we've seen the or, and now we've seen this XOR. And now with these, I can have a combination of like minus P and Q or R, and then I'm going to ask you to tell me, okay, if P is false and Q is true, sorry, P is false and Q is true and R is true, what is going to be the result of this? Is it going to be true or false? So that's the thing. Or I'm going to ask you even more. Okay, construct the truth table of this here. What is the truth table? Basically, that means you have to do this P, Q, R, and then maybe to have, this is the first part where you're going to prepare all the possibilities. And if you have to prepare all the possibilities, that means it's going to be true, 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 false, true, false, true, true, false, false, and then I don't have plenty of space left, false. That's why actually it will be better for me. Actually, I prefer to use this thing here. So that means I can move things around. So I have P, Q, and R. And they said we want to see the not P. What did I say first? Oh, I removed it. Where is the thing? Did I stop it? Oh, it's here. I stopped it. So okay, I'm going to give something else. Or Q and R. So this is the result I would like to get. Okay, no. And then why I left some space, because I said not P, that means I would like to have this not P as well, so I can easily, when I'm doing the comparisons, I would like to be able to see which one is going to be which. So this is true, true, true. So I'm going to say T, T, F, T F T T T F F, and then I have F T T F F F T. What did I say? Yeah, F T. I'm doing something wrong. It's going to be much longer. FTF. Maybe I need to use. Okay, what are the combinations, the remaining ones? Okay, here's this. So we said F, TFT, TFF, FTT, FTF, and then F, FT, F, F, and F. Somebody has a question? No? Okay, so now what I need to do is also I need to represent this minus this negation of P or minus P. So how to do that? Okay, come on. Oh, that was not it. Maybe that was the brush. Yeah. Okay, so that means for every here is going to be T. Well, that means becomes F. The not P. I'm going to only focus on P, and then so I'm going to have F, 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 and then T, 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 and go down a little bit, and then T. So now when I'm going to do this and an or, it's not going to be easy for me to do it this way. So the best way is actually to do it by step. So the step by step, let me select something. So I'm just going to, what? No. How to do the selection? I'm just used to, okay, it's done, right? Okay. Okay. So I'm just going to start by all right, so it's and then how about this, and move it here. I'm going to start by this, and then the last one is going to be the final one now. Okay, I forgot to enable it. Is not P, we said or, Q, and R. So we try to do that step by step to be able to answer that question. Okay, so we said we did the not P, and then we need to do this Q and R. Okay, so Q and R, that means with the end, if one of them is false, all the things are going to be false. The only time this is going to be true if both of them are true. So I'm just going to watch these two. This is going to be true, true, gives me true. True, false, that's false. That's false. Other false. And then here, TT, that means that's true. TF, that's false. That's false. And keep going down. This is again false and false. I hope I did not mess up. 2, 4, 6, 8, 9. Something is missing though. Because normally it should be 2, 4, 6. 2 to the power of 3, right? If you have 3 to the power of 3, that means 2 times 2, that's 4. 4 times 2, that's 8. I should have 8. What am I having here? 2, 4, 6, 8, 9. So I have one extra that is not supposed to be here. Okay, let me select. Can I select? No. Oh, okay. So I think I just missed my alignment. Yeah, it looks no. Okay. Yeah, I missed my line. Okay, so now that with this now, I need to have an or between this one. No, between this one or this one. And with the or, how does it work? If one of them is true, the result is going to be true. The only time this is going to be false, if both of them are false. And now I have ft, that's going to be true. False and false, it's false. False and false, that's false. False and false, another false. And then true, and then true, and then true, and then true. So the only time is going to be false is both of them with the or. It's both of them when they're false. And this is how we're going to be constructing some truth tables. Actually, truth tables can be also used to check that two can be equivalent. How can I say something equivalent? For example, how to prove that two different things are equivalent. I can use the truth table to show that it's actually one of the ways how it is equivalent. Any questions? So far so good? Yep. Please, go ahead.
Doctor, are we gonna to be asked to make a truth table ourselves, or it's gonna be written just we have to answer the truth table?
Well, you might have to actually draw these truth tables. Yes.
Okay, thank you.
Welcome. All good? So this is go back to the talk about the inclusive and exclusive disjoint. So basically the idea, we mentioned it, is that for the exclusive, if they are the same, we don't want that. If they are different, then it's going to be true. So if they are the same, regardless if it's true or false, it's going to be false. That's how the exclusive or work. The inclusive one, that means as long as one of them is true, the result is going to be true. It's going to be false only if both of them are false. And so now there's also something that also you've seen most likely, but this is sometimes some students struggle with that in programming. Like if we have an if we have some sort of if, let's say P and let's put it in Java, right? All of you finished Java 1, I'm guessing. I think so, right? Because you should have finished it. So let's say if P and Q, then you do something. Maybe just I'll put the do somethings next to that because I have a lot of space. Then you do something else. You do something else. Now sometimes I would like to actually, whatever it's in, this is the else, I want it to be in here. So let's say this is some kind of code, this code block of code. There is going to be some kind of maybe let me do something x equal 5, and this here is the x. Where is it? It goes, okay, x. Sorry, sometimes I lose where it's x equals 0, something like that. If this is true, I'm going to do this x equals 0 here. Else, x equals 5. But then sometimes some students struggle with, I tell them, okay, what if I would like to remove this here and swap them? I want this to be, the 0 should be here, and the 5 should be here. That means now I need to do the opposite of this, the negation of that. That means I want the opposite of P and Q, because this is not P and Q, this is what I end up here, I will end up in the else. Now if I swap these in places, that means I want this to be not P and Q. So what you can do is to just, in Java, basically, you can just do something. Let me just remove this. You can just do this. not, where is it again? Here. Not, and then put the parentheses. But you can also, instead of doing the not and the parentheses, you should know that actually this here is the negation of this. So this is the negation of this, will become exactly like this, which means the not P or Q, okay, where is this here, is going to be exactly as not P or not Q. So this, the negation of the and becomes or, and the negation of the or becomes and. So that's the idea, and this is sometimes some struggling issue with, for students. So that's why, I mean, this is one of the reasons why we take this course, because it allows to have this flexibility of understanding. If I have P something that is can be true or false, and this is or something that is also true and false, and I want to have the negation of it, so not all of these is going to become, is not singly every single one, and then the not of this one is going to give you to the or becomes an and. So that's how the negation of this is this, and the same thing, the negation of this is this thing. So the and becomes the or, and the or becomes the and. And of course you have to negate all the propositions as well. I think it's okay, right? This is just like some examples on in English how to do this. Let's have a look at one, for example. I am both rich and happy. So if I want to negate this, that means I am not rich or I am not happy. I'm not rich or I am not happy. So that's the negation of that. I cannot say I'm not both rich and happy, because that's actually, yeah, that's a way to say it. I'm not both rich and happy. So you just, that means you're not rich and happy at the same time. So either you're not rich or you're not happy. And with the or, remember, this can be true, this can be true. And this is going to be both of them. I cannot be not rich and not happy, but maybe I can also be rich and I'm not happy. Or I can be not rich, but I am happy. So the idea is the following. If we negate an or, it becomes an and. And if we negate an and, it becomes an or. I don't want to spend too much time on this. If you still have some questions, just stop me, please. Now, this one is called the conditional statement. Now, this one has a tricky part, and this is the one that requires your attention. Like, if you did some kind of quick review before this, if you had access to the slides, you see this, you'll find it a little bit odd at some point. So let's try to have a look at this. Let P and Q be propositions. That means P can be true, false. Q means it can be also true or false. That's what it means. The conditional statement P and this symbol Q is the proposition that if P, then Q. This is how we read it. This arrow over there, this arrow over here, it means if P, then Q. But also this here is actually sometimes not easy to get, and I'll understand and tell you why. The conditional statement P, if P, then Q is false when P is true and Q is false, and true otherwise. That means this here is going to be false only in one case. What's that case? If P is true, but then Q is not true, it's false. Everything else is going to be true. So let's try to understand this. If I have P, then I have Q. It makes sense. So it should be true. If I have something, then I got something else. That means it should be true. Now let's have a look. Maybe if I say P is I'm rich, just to take the previous example, and Q, I am happy. Now if I say P, if P then Q, that means if I am rich, then I'm happy, right? So if P stands to be true, that means I am rich. If I'm looking at here, so you have to look at one line at a time to see, actually, to be able to understand how this works. Let's look at one line at a time and see the result that it gives us and try to make sense of that. So let's be here at this time. I'm just trying to not take too much space. What happened? I erased everything. That's why, actually, you know what? Control print screen. That's why I'd rather do this. Yep. So it will be much easier for me to do Control Z that I cannot do during the presentation. So let's now also bring it red, so it will be much easier. So now if I'm here, okay, if I'm here, and I say that P means I am rich, and Q, we said this means I am happy. If P is true, I'm looking at that row over there, right here. If P is true, that means I am rich. And here it says, if I am rich, then I am happy. Well, this is what it means. If I am rich, then I'm happy. Then I'm happy. So it should be. It makes sense maybe at some point. So, if I'm rich, I am happy. So it seems to be okay. I don't know why I did something. It's easy to Control Z. And the brush. Now let's have a look at this one. If it's true that I'm actually rich, and then I'm happy, so I'm actually not happy. Q is not, says not happy. So if Q is false, that means I am not happy. Now my inputs are P is true, that means I'm rich. And Q, that means I'm not happy. That means if I say if I'm rich and then I'm happy, then it says here no, because actually I'm not happy. And it says, okay, this is false. So if this is I'm not happy, this is false, then it gives me false. But if this is true, it gives me true. That makes sense, because so far this, if I am what I say that I am, then I'm going to be the result of whatever this is going to be. But let's have a look at the other two. Let's say I am not rich and I'm happy. It says like if this here means if I'm rich, then I'm happy. But actually I'm not rich, but I'm happy. And still this is telling you if P then Q, the result is going to be true. So it seems like this kind of conditional statement is not actually what matters. It doesn't matter what you start for, because what it says here, basically at the end, I was trying to make it more practical, but it became a little bit confusing. So what I'm trying to say is that this part of P, it does not have a lot of effect on the outcome like the Q has. Notice here, if Q is true, it's true. Q is false, it's false. Q is true, it's true. But here Q is false, it's true. That's the only time where here. That means I am not happy. If I'm not happy, then I'm sorry. If I'm not rich, then I'm not happy. It still gives me a true. But why? Well, that's why I was trying to give you that this if I'm rich, I'm happy. It becomes a little bit confusing about that. So the idea that okay, maybe I should find a better example, but for now, what I'd like you to just remember that this conditional statement if P then Q is going to always be Control Z. It's going to always be true unless Q is false and the P is true. If regardless of P and Q, if they're true and false and false, it's going to give me the result is going to be true. The only time that is going to be false is that if the initial one is true and the resulting one is false, then I get the false. Anywhere else, this is going to be true. And that's actually this conditional statement, which is going to be false in just one case. It's like the or, but in different way. Because the or also is false in only one case, if you remember, with the or, not the exclusive one, the inclusive one. This or, all of them are true except for one case when we have both of them are false, while this conditional statement, they're all true except for one. Okay, which one? Well, I have to start with something that is true that gives me something that is false. This is something that's false. If something is true and it gives me something true, that's true. If something is false but I still have something that is true, it's going to be true. And if something is false and it gives me something that is false, it's still true with this statement. So the only time it's going to be false if you give me something that is true and I give you something false. I mean, that's how you try to remember that. So try to remember only this condition here that gives you that outcome. The other ones are going to be true. I'll try to see if there's some examples here that explains that conditional statement even more. So let's have a look. So they say here, because conditional statements play such an essential role in mathematical reasoning, a variety of terminology is used to express if P then Q. You will encounter most of, if not all of the following ways to express these conditional statements. If P then Q, this is what was mentioned initially. We also have P implies Q, P only if Q. A sufficient condition for Q is P, Q whenever P. But anyways, none of them are going to be, maybe this one is going to say the Q unless not P. That means it's going to be whatever Q is unless it's not the P, which if we look at it, what is not the P? So I'm trying to unless make sense of this, but actually I'm just making it even more complicated. So anyways, these are all different terminologies that mention the conditional statement. If something, then something else. But actually I'm still trying to find some maybe better examples. Okay, let's have a look. A useful way to enter the table for the conditional statement is to think of an obligation or a contract. For example, if the pledge many politicians make when running for office, that if I'm elected, then I will lower taxes. Maybe that's a good example. If the politician is elected, voters would expect this politician to lower the taxes. So let's say this is, if I'm elected, this is the P, this is my pointer, okay, this is the pointer. If I am elected, this is the P. Then I will lower the taxes. This is the Q. Let me just finish this and then I'll take the question. If I'm elected, then I will lower the taxes. So if the politician is elected, that means in this case, I'm trying to here. If the politician is elected, then they would expect that he's going to lower the taxes. So lower the taxes means Q is true. So that means this is going to be the statement that is going to be correct. But for this case, it's going to be correct. What if then he does not lower the taxes? So he said that if I'm elected, I'm going to lower the taxes. But at this point, he did not lower the taxes because we're in this position. That means the result is going to be F. Then if he's not elected, basically the taxes are not going to be lowered, but maybe someone is going to lower the tax. The person that was elected might lower the taxes or might not lower the taxes. So, and even if might not lower the taxes, because that person who was saying that, he did not got elected, so that's why this statement is still true. It's still valid. The only time the statement is not going to be valid is that after saying that he's going to, if he's elected, he's going to lower the tax, he did not lower the taxes. So that's why then this statement is going to be wrong, false. So yes, some people raise their, people wrote things. Okay, what was that? It's good. If I studied hard, I will get an A+. Okay, that's a good point. Let's try that. If I studied hard, I got an A+. Let's do this, and let's erase that somehow. I'm going to erase this, and let's erase those. Anyways, not to be hard. So if, okay, Control Z, if I study hard, I will get an A+, inshallah. Now, if you studied hard and you got an A+, that means this sentence, if I studied hard, I will get an A+. That means it's going to be correct. Now, if I studied hard, but I did not get an A+, that means this statement that if this then that, or studying hard implies that I'm going to get an A+, did not work. Was not correct. Well, it gave me a false result. Now, if I did not study hard, but then I got an A+, this does not negate the fact that, well, the result is that this condition that says if you studied hard, you get an A+, does not mean that if someone does not study hard and get an A+, that this means this rule is wrong. That means if you study hard, you will not get an A+. So that's why this is going to still to be true, even though in some cases you did not study hard, you do not have the precondition to make it happen. So if you did not study hard, let me just remove those. If you did not study hard and you still got an A+, the rule that says that if you study hard you get an A+, does not mean it's not working anymore. This is still okay. I mean, it does not break that rule. That's what this true means. As opposed to here, I mean, if you study hard and then you don't get A+, well, that rule is broken. That's why, I mean, you can maybe find this F making more sense. What about this one then? I did not study hard and I did not get an A+. And this is still giving me, this is correct. Well, because if you did not study hard, Allah Alam, what happens? You may get an A+, you may not get an A+. This is what this says. You may get an A+, like in the first one, or you may not get an A+. So you may get an A+, you may not. But in all the case, the rule is still valid. The rule that says if you study hard, you will get an A plus is still valid. It just you did not take the means to apply to it. So that's, anyways, another way how to look at it. But for me, what I suggest you always try to do is to remember that there's only one scenario where this conditional statement is false, is that when you start with the true and you end up with the false. Anything else is going to be true, true, true. So that's the way how to try to remember it. Okay, what happened? No. Okay, can I cancel? Cancel? No, there's no way to cancel. Shift F5. Okay, so I think we spoke enough about this conditional statement. And there's another example here. If Maria learns discrete structures and Q, the statement Maria will find a good job. The expression as set in English. So, well, this is a truth table, so that means if Maria learns discrete structure, then she will find a good job. So this is the first part over here. That there may a way to express this condition in English. Among the naturals of these, Maria will find a good job when she learns discrete. I mean, they try just to explain this maybe in different ways how to match that. They're talking about this case over here. All right. Now some different words, different terminologies, which are these converse, contrapositive, and inverse. And if we have, I'm trying to find my, yes, if we have this statement, the conditional statement, if P then Q, if you reverse them, this is called the converse. So the converse is, the converse of this is going to be this here. So that's what it means. Like the converse here, the converse of P, if P then Q, is the proposition if Q then P. So that means just you flip the order of them. The contrapositive of P if P then Q, then is not Q. If not Q, then not P. And the inverse of if P then Q is the proposition if not P, then not Q. Basically, the converse is that you flip them. You just flip. The contrapositive is like the negation of the flip. And the inverse is the negation of the conditional statement. If the negation of the conditional statement. So that's just different names that you have to just get used to. So if we find something that says, okay, what's the converse of this, you should be able to just give the answer to be this. Is that okay? Is that okay? So just some terminology. Okay. All right. Now, these are basically just some examples again. This, if I'm rich, then I'm happy. Then the negation of it, because the negation of P and Q Causative, I don't know what they mean with that. For this statement to be false, I would need to be rich and not happy. So, I mean, they're trying just to explain this part over here. I think we spoke enough about those. Some examples. What are the contrapositive, the converse, and the inverse of the conditional statement? The home team, if the home team wins whenever it is raining. Okay, so again, this whenever it is raining, this, I'm just trying to again to sign. So this is whenever it is raining and the home team wins. This is actually the result of this if. So if P, then Q is going to be represented with this thing over here. Now, this is the conditional statement. We'd like to have the contrapositive, the converse, and the inverse. So let's start with the converse. You remember the converse is, the converse is when we just flip it. The contrapositive is that we just negate the flip. Negate the flip. And then we just negate the conditional statement. Conditional. So let's do the converse. If we do the converse, that means we should have the converse. It's that Q, if Q, then P, which means it is raining. Oh no, I pressed. Okay, I pressed this. Okay, let me just write it here. The converse is that when we flip, the contrapositive is that actually we negate the flip, and the inverse is that we negate the conditional statement. All right, so that's the inverse. That's the converse, that's the contrapositive. Now, if it says the home team wins whenever it is raining, that means if it is raining, then the home team wins. This is actually what we've seen in some of the here that says this one over here. Whenever is. So this is the result of that. That means we can okay, hold on. We can just write this differently by saying if it is what did I do? No, I don't want that. Okay, cancel this. Okay, what should I do? Keep. Okay, Shift F5. Okay, so I said if it is raining, I'm not writing properly. So if it is, or it's raining, then the home team wins. That's the same thing. Now, if I would like to say the converse, that means if the home team wins, then it's raining. That's the converse, which is just we flip them. The contrapositive means I just need to mention if the home team does not win, then it's not raining. I just do the negation of every single one of them. So if you remember, we said the contrapositive is that it's not Q, then it's not P. So we just negate each one of those, negate whatever was in the flip. And let's see what they give here. So with the converse, they say if the home team wins, then it is raining. They say if the home team wins, then it is raining. Okay. Then the what is the contrapositive? If the home team does not win, then it is not raining. Okay. And then what's the remaining one? What was the inverse? That means if it is not raining, that means the inverse, if not P, then not Q. So this is our P and this is our Q. So if not P, if it is not raining, so this is if it is not raining, then the home team does not win. Then the home team does not win. So the point here is the last sentence right here. So you see what it says is only the contrapositive is equivalent to the original statement. The contrapositive, this here, is equivalent to the original statement. So what they're saying now is that maybe I can leave that here. I will do that later. What they're saying is, okay, come here. If P then Q, this is equivalent, and this is how we represent equivalent, to not Q give you not P. Right? So they say the contrapositive is equivalent to the original statement. This is how we represent equivalent. Now, how can we check? Now, we can check that by doing something very easy. Let me just copy this. And I'm just going to, what am I? Control V, okay, here. So this is a table. I just would like to paste it again empty with nothing and paste it just enough. Let me paste it here. So I don't want to have that one. And what I would like to do is to add to this the truth table of this one over here. Okay. So to be able to do that, I would like to include, to make it easy on me, to include this not Q and not P. So I can just do the same thing here. So I'm just going to keep that, and I'm just going to mention this not Q and not P. So at the end, I'm just going to check if not Q, then not P. And if I'm able to find the same sequence of values, true and falses, if they're the same, that means these two are equivalent. This is how we can check and do some kind of proof that these two are equivalent. Okay, so where's my cursor again? Okay. So not Q here. Every time it's going to be T, I'm just going to make false. Every time it's false, I'm going to make it true. I will try to stay on the same rows so I'm not making something confusing. And this is just the opposite of whatever I see here. Now same thing with the P. Whatever it's going to be true, I'm going to make it false. Whenever it's going to be true, this one is true, false, and then true, true. Now if you remember what we said about this here, this is going to be always true unless the first one is true and the second one is false. Right? That's what we did. The first one is true, the second one is false. This is what the only time it's going to give me false. Anything else is going to be true. So let's have a look at here. The first one is true, the other one is false. That means the result is false. Anything else, this is not the first one true, the other one false. That means this is going to become true. This is not first one is true, the other one false. So it's going to be true. this is not the first one is true, the other one is false. It is true. And as you can see, these two gives me the exact same result for the exact same input. So my input is P and Q. My output for this if P then Q is this. And my output for if not Q then not P is exactly the same. This is how we can prove that P, if P then Q, is equivalent to if not Q then not P, which goes back to the last statement that means that contrapositives are exactly the same as original statement. I hope you're still with me. The only problem is actually these lectures are kind of long. 3 hours is a little bit of wrong, and there's no like, if you want us to take some break, we can take a break. However, we will finish later. But you tell me, if at some point you need some kind of 5-minute break or something, we can do that. I mean, but remember, we need to get back to that. I mean, to try to match the time that we have. What I'm trying to do is, let me see my timetable first. All right. So this is the idea. I'm also going to make my timetable available. So see, for example, we say this is 9, 10, 11. So that means we have a 10-minute break between the two. We can just push that 10-minute break towards the end. And then this 11 we have again between 20 and 30, another 10 minutes. That means we can push it 10 minutes and 10 minutes, which means our official end time is, if we push all the breaks towards the end, it's 18:10. We remove 20 minutes, it's 18:00. That means at 6 p.m. we stop, if we start at 3:30, inshallah. But if we take some breaks, we can take the breaks, no problem. We're just going to push our end time later. But it's not a big deal. Just let me know, inshallah. So far, we still have Maghrib time at around that time, but it's okay. If you feel that we need to take a break, we can take a break. But I suggest we just keep going. And if something is not clear again, you can just ask a question, ask me to explain more, whatever, if you feel that way. Oh, that's what I'm guessing. Everyone wants to finish early. I'm guessing that. Yeah, that's not only your opinion. I'm pretty sure. Anyways, but just bear with me. If you see that, I mean, it's becoming a little bit overwhelming, just, okay, give me some kind of stop. All right. Now, we've seen the and, the not, the and, the or. These were like the easy parts, so it's kind of easy. We've seen the negation operator with the not. We've seen the conjunction. This is the and. We've seen the disjunction, which was the or, and then we've known that there's two types of disjunctions: inclusive one and exclusive. Inclusive is the one that the or that we know, and there's another one that is exclusive, which is the XOR. And then we started with these conditional statements: if this, then that. And now we have some different terminologies regarding these different conditional statements: the converse, the contrapositive, and inverse. Well, you have to get used to that. Just try to find a way to remember them. And that's why I use this flip, for example, so you can just maybe try to remember it easily. And then now we're talking about the biconditionals. I mean, this is another representation of that. Let me just again bring back, the pen, which is this symbol over here. And this biconditional statement is the proposition that if the P is if and only if Q. Now, sometimes they refer to it as if like this is. So P if and only if Q. And the idea behind that is that it's going to be true if P and Q are of the same state. If both of them are true, both of them are false, that means if both of them are true or both of them are false, if they have the same value, then this is going to be true. If not, it's going to be false. So if one of them is different than the other, it's going to be false. If they are the same, that's going to be true. This is called the biconditionals. So the biconditional statement. So the truth table of the is shown in table 6. Okay, note that the statement P, if P and P if and only if Q is true when both conditional statements P and Q are true, and it's false otherwise. Well, basically what they're trying to say here. Okay, let me show that. Let me try to show this to you. What they mean with that. Let me bring it to here. Again, we're going to do some proof by the truth table. Okay, so I was saying that I'm going to again do the same proof by using the truth tables. So what they're trying to say here is that, okay, they're trying to say that, maybe let's go back down here, that P if and only if Q is equivalent to if P then Q and if Q then P. All right, so to prove that, to test that, what we need to do is to, based on these inputs, we need to calculate what are the results, to draw the truth tables of if P then Q. I need to just be more careful about my lines. Okay. All right, and then we're going to also find the truth tables of, all right, if Q then P, and then we are going to be doing an AND with if P then Q and if Q then P. And if we have, again, these results here are going to be the same than these for the same inputs, that means they are equivalent. So let's find out. Now, if you would like to, participate, just activate your microphone and talk about it. So we have if P then Q. That means, remember, this is going to be true all the time except when the first one is true and the second one is false. That means this is the time when this is going to be false, and every other time is going to be true. Same thing for here. If Q then P, that means I'm going to look on the other side. If this one is true, the other one is false, then this is the time where this is going to be false. Every other time is going to be true. I don't want to go too fast. Stop me if you're confused about this one. So what I did, I just looked, this one is the first one, should be true. The other one is false, then this is going to be false. Every other time is going to be true. So far, so good? That means let's do the AND. The AND is going to be true if both of them are true. So this says both of them are true, that means this is true. Not both of them are true, that's false. Same thing. Both of them are true, that's true. And then we can see that these have the exact same results. So the biconditional are basically this is what it says. It just gives you that both the if P only if and only if Q is the equivalent of having if P then Q and if Q then P. That's what it means. And there's also another ways to mention that, is that P is necessarily insufficient for Q. If P then Q, and conversely, that means and the opposite, P if and only if Q. This is actually another representation of this symbol. And that's what it says, that they have the same truth table than this thing. That's what we just mentioned. And there are some kind of examples for those different statements. Let's see if VQs are valid. That is when you do not buy a ticket, but I think, I'm not sure. I'll just like to move on because I'm looking at the time. I don't want to spend too much time and leave behind the others. Okay, truth tables of compound propositions. We did some. So we did some of these by when I was doing the exercises, the examples. So when we do something like this, I would like to have, okay, what is the truth table of that thing? Where's my cursor? Okay, here. See, when we did this, remember, so this, now if this can be a question, now to do that, we're just going to prepare all the different components that we have. We don't have this not Q, so that's why they made it, they prepared it. And then it's going to be just the opposite of what we did. And then the first thing that they did is this part over here. So then they did this one. And then they did the other part, which is this one. This is the or, and this is the and. And then they use this conditional statement. And then they end up with this result. So basically, all you have to do is to start with these and then add the ones that you need to be able to, that are going to be helping you to reach your solution, because these are the ones that you need to combine with others to be able to get the right answer. So again, if we have these to be true and false, etc., this is going to be this if then that is going to be false only if the first one is true and the other one is false. So in this case, this is false, and this is also going to be false. Every other time it's going to be true. So that's yeah, that's how we do that. So I think this is going to be not a big deal. Now, one good question is, when we have all of these, what's the precedence? Remember, the precedence is which one we start with first. So if there were no parentheses, you're still going to be starting with something. Let's say if I gave you this, like this, P or not Q, and conditional statement, P and Q. So which one are you going to start with first? Well, the first one we start with first is this negation. That's why this is the discussion that we're having right now. This is the precedence. The first thing we start with, if I find my cursor, okay, the first thing we start with is this negation operator. Then the and and or. We put them 2 and 3, but it's not really necessary to be 2 and 3. It can be 3 and 2. They're both of them at the same level. It does not mean that this one is first, this one is second. I mean, the first and second, it means that. But for those ones that are on the same level, these ones on the same level, it's this numbering. It does not make any difference for them. So it could be 2, 3, or 3, 2. It's not a problem. Same thing for this, 4, 5, or 5, 4. It's not a problem. So then this conditional statement or big conditional statement, these are coming the last. So that means if I just give you this and tell you, okay, find the truth table of that, what you're going to be doing is that the first one is the negation, then you're going to do the or and the and, or the and the or, doesn't matter, and then you do this conditional statement. That's what this whole thing means. So they come in a group, in this, like as shown here. These ones, they have equal rights. So if they have equal rights, same thing like we have with the plus, minus, multiplication, and division. So these two, they have equal rights, but these ones have higher priority. The multiplication and the division have higher precedence as of this. And actually, if we need to do this, there's also a negation is one of the operators that are the unary minus. Now, I don't know if you know what I'm talking about when I say the unary minus. And then you have the plus and minus. So what is the unary minus? This one, for example, if I tell you 5 multiplied by minus 2 plus 3 divided by 2. So which one are you going to start with? Well, this is the first one. This is minus 2. This is the unary This is the negation. And then you have a multiplication, and then we have the multiplication. And then you have here a plus, but then you have a division. So you do the division, and then the multiplication, the addition is going to be the last one. But what if you have 5 plus 2 minus 5? These two are on the same level. So which one you start with first? From the left to the right. Right? This is what we've learned in Java 1. And, well, basically, the same thing happens. It doesn't matter if you put, for example, something like this. So you start from the left to the right. So that's... hold on. Am I saying something wrong? They say here, another general rule of precedence is that the conjunction operator takes precedence over the disjunction. So that's actually really the 2 and 3. I was thinking it's like the multiplication and division. It seems like it's not the case, but I'm not sure though. If I do P, R, Q, and R, that means if I start with this one, is it going to be the same that if I start by doing this one, or is it going to be the same as this one? That's a good question. Let me try something. I remember in the beginning we have this here. So we have these ones. I'm going to copy those. And I'd like to test, just to know if I'm right, or I just said just a mistake. Just quickly. So if I have this, oh, no, that's too much. So if I do, okay, here, P, so my point here, I would like to prove, to know if you have something like this, Q and R, they said that the precedence, this should be this. And my point, I was saying that this is going to be exactly the same as this. So I said, in my understanding, they are the same. They're the same level. But there I was reading something different. So I'd just like to prove that these are the same. If they are the same, that means, based on using the truth table, that means I'm right. If they're not the same, that means there's a precedence that actually needs to be applied. So if we have something like this, for example, P, or Q, and R, according to what they said, I should start with this first, and not from the left to the right. So that's what I'd like to prove. So in order for me to check that, what I'm going to do, I'm going to start with one of these, and then I'm going to check. So to check this one first, what I'm going to do is I need to have this Q and R. So let's just put Q and R. And then I'm just going to put P, or Q and R. And then I'm just going to go down later on. Maybe not go too down. Okay, let's just be here. And then here I'm just going to calculate for the other one, which is going to be P, O. Let's go. And where am I? No. Okay. This is why I want to be here, because Control Z is a blessing here. P or Q. That's what I'm going to calculate. And then I'm just going to have P or Q and R. So let's do that, the first one. Q and R. And that means I'm just going to be a little bit fast. Every time it's both of them are true, it's going to be true. If they're not, it's false, 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 true, false, false, false. If you have some question, you just stop me. And I should have actually, let me just take this whole thing and move it a little bit so I can have some space for the others. All right. Okay, let's get back to my brush. So now P or this one. With the or, as soon as just I'm looking at P or this one, as soon as one of them is true, the result is going to be true. So this is true, 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 false, false, and false. Remember, I'm looking at the first column with this one over here. So this is the result. Let's now do this one, P or Q. P or Q, that means if one of them is true, the rest is going to be true, 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 and true. Let's go down. P or Q. Okay, so we said that this is false and this is false. Now P or Q and R. Okay, so that means, where are you? With the end, both of them has to be true, true, false, 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 true, false, false. I lost something. Hold on. I was looking at the wrong place. Yeah. So I'm looking at this one, this column, and this column. So that's why I was looking at the wrong place. This is true, this is false, this is true. This is false, this is true. This is false, and this is false, and this is false. Are they the same? And they don't look like the same. So they're not the same. So what I was saying was false. I was saying that they have the same levels. No, they're not. They don't have the same levels. Which means actually 2 is for the end, and then the or. So if I have something like P, so this is what they said. Okay, here. If I have P and Q or R, this has to be to 1. If I have P or Q and R, that means I'm going to do the and first. The or will come later. And I think that was a good thing that we did it. And same thing with this 4 and 5, with this conditional statement and be conditional. The last thing I'm going to just to talk about is just the logic and bit operations. Many of these, actually, the representations of true and false are going to be zeros and ones. 1 represents the true, and 0 represents the false. And basically, I mean, we can do some kind of like a string operation of trues and false, and then you can do this truth table using this or and and, but it's just a different way how to present them. Why is that? Because actually the and the or are some kind of operations. So and or is actually some kind of plus or wise, or and sometimes it's like you move around some bits from one place to another. I don't want to get into a lot of details, but actually you can do these operations, this or and XOR and not. They can be just some kind of bit operations that can be something very easy to implement internally in terms of the hardware. But I don't want to talk about that much, just to give you an idea that we can also represent those true and false with zeros and ones, and that's pretty much it. So now, we will finish with this, inshallah, almost hopefully, inshallah, within the time. We'll have 6 more minutes. We're going to just to do this. Now, just quick questions, and try to answer them. Open your mics if you want to, that's a good time. And if you'd like to answer them, just go ahead. Suppose that during the most recent fiscal year, the annual revenue of ACM Computer was this thing, and its net profit was that. The annual revenue for Nadir Software was 87 billion, and its net worth profit was $5 billion. And the annual revenue for, I don't know what that media thing, was $111 billion. And the net worth and the net profit was 13 billion. Now determine the truth value of each of these propositions for the most recent fiscal year. So you just look at this proposition and tell me if it's true or false. So this media had the largest annual revenue, true or false? Just say it. I don't want to swap flip-flop. Okay, just let me just swap so I can see what you're writing. False?
False.
So the largest revenue, is it the largest revenue? Okay, so they have, this thing had 13 billion in net profit, but it was $111 billion in the revenue. So this is, the revenue is this one. But this here had a much higher number. So, as you said, this is false. Okay, now this software had the lowest net profit, and ACM computer had the largest annual revenue. So now we have two things. This one and that one. Now, if we use the and, that means both of them have to be true in order for it to be true. So, what's the answer? True, true, true. So that means both of them are true. Now, this software had the lowest net profit. 8 billion is the lowest net profit. Is it? I mean, the lowest seems to be 5. But we're talking about Nadir. Sorry, I'm mistaken. Yeah, it has the lowest. Yes, so that's true. And ACME had the largest annual revenue. Annual revenue. Okay, again, annual revenue is this one over here. And yes, it is true. So true and true, that's true. Let me see what some did. False, you mean true? Okay, true. True, true, true. False, true. Okay, so I think I was also confusing a little bit, because when we talk about revenue, we need to look at the first number. When we talk about profit, we need to look at the second number. So Nadir, okay, Nadir here, had the lowest net profit. That means you look at the number here. The lowest number is 5, so that's yes. This one is true. ACM computer had the largest annual revenue. Revenue is on the second hand. I mean the first part. So let's have the first number. This is the largest. Yes, it is. And okay, what about this one? ACME computer had the largest net profit, or this media had the largest net profit. So let's have a look at the or. One of them is true, is enough for the whole thing to be true. So ACM had the largest net profit. Net profit, that's on the right side. So this is false, right? So this one is false. The next one had the largest net profit. Well, yes. So because of the or, true is the right answer. Correct. And then if Kinexmedia Media had the largest net profit, then ACME computer had the largest annual revenue. So now we have this conditional statement. So it is going to be false only if this one is true and this one is false. Everything else is going to be true. So this Kicksot Media, I don't know how to, had the smallest net profit. Kicksot has the smallest net profit. Well, that's false. Then ACME computers had the largest annual revenue. ACME, largest annual revenue. Well, that's true. That means true. That's correct. So the statement is true. Good job. Okay, there's a last one. The Deer software had the smallest net profit if and only if ACME computers had the largest annual profit. You remember that with the if, only if, that means they have to have this if. Both have to be true, so it can be true, or both have to be false, so it will be true. Anything else, it's become false. So this is the representation. Let me just go back to pen, and this is, we're representing one like this, right? This is the if and only if. Is that it? So Nadir had the smallest net profit. Net profit, Nadir's net profit, the smallest net profit. So this is true. And ACME computer had the largest annual revenue. Largest annual revenue, ACME. That's true. So the result should be true. Someone is raising the hand, or no? Poor connection. For right now, others will see a video in lower quality. I hope not. So anyways, go back here. Okay, what's happening? Okay, doesn't want to discard. Shift F5. Okay, we did this, so it should be true. Okay, what about this? Which of these statements are propositions? What are the truth value of those that are propositions? Riyadh is the capital of KSA. That's proposition, it's true. Remember, proposition is something that can be true or false. Rome is the capital of France. It's a proposition, but it's false. 2 plus 3 equals 5. proposition or not a proposition? It's a proposition, yeah, okay. And it's true. 5 plus 7 equals 10, it's another proposition, but it's false. This one, x plus 2 equals 11, that's not a proposition, correct? X plus 2 equals 11, it's not a proposition, and answer this question is not a proposition either. Okay, how about this? If P and Q are swimming at the Jubel shore is allowed, and sharks have been spotted near the shore, respectively. So this is P, this is Q. Express each of these compound statements as an English sentence. So not Q means this is Q. That means sharks have not been spotted near the shore. All right. P and Q. That means swimming at the Jubel shore is allowed, and sharks have been spotted near the shore. So just these two together with this and in the middle. And not P or Q. Not P, that means swimming at the Jubel shore is not allowed. That's not P. Or shark have been spotted. Swimming at the Jubel shore is not allowed, or shark have been spotted near the shore. Correct? How do you decide which of which what? What's the question? One is P, yeah, it says respectively, that means this one is P. The first one is P. This one is P. And this one is Q. So because it says that P and Q be the proposition, so this is P, that is Q. So that's, yeah. So knowing that this is P, no. This is P and this is Q. Now if we do this, if swimming at the Jubel shore is allowed, then sharks have not been spotted near the shore. So because it's not Q, and we just negate that. So if swimming at the Jubel shore is allowed, then sharks have not been spotted near the shore. All good? Any something? Everybody's okay? Okay, an extra 2 minutes. I'm just going to finish. Okay, just one last one. What is the negation? I mean, the way this is a kind of, okay, easy to do. Okay. How many rows appear in the truth table for each of these compound propositions? Okay, that's a good point. Now, if I'd like to do this, how many rows do I have in each of these tables? If I'd like to calculate, to draw the, or to illustrate, or to draw the truth table of this one, number A. So how many rows would I have? Now, let me remind you of how to calculate that. I just see how many variables do I have, how many propositions do I have, and I put 2 to the power of that n number of propositions that I have. So how many propositions do I have there? I have 1, right? So 2 power 1 equal 2, yes. How many here? 2 to the power of 2 to the power of 4, exactly. That means 16. Am I right? 2 times 2 times 2 times 2. So I mean, this is 4, this is 4. That means 4 times 4, that's 16. What about this one? P, Q, S, R, T, U. Okay, how many? 1, 2, 3, 4, 5, 6. That means 2 to the power of 6. Now, what is it to the power of 6? 64. Good job, mashallah. 64. What about these ones? P, R, T, Q, T. That means I have 1, 2, 3, 4. T is repeated, so I don't have to repeat it again and count it twice. I just count it once. So that means it's going to be 2 to the power of 1, 2, 3, 4. Which is going to be 16 as well. Let's compare 2, 16, 64, 16. Yes. And construct the truth tables. This is something that I leave for you to do at home, inshallah. If you have any problems, I mean, you can still look at the solution and to compare it with. Same thing with these ones, and you have the solution. I'm just going to share that. And also we have some additional exercises if you'd like to practice and do that. And this is some take-home exercises. And that's pretty much the most beautiful slide ever. When brings peace of mind. I think I can now. Any questions? I'm just going to stop the recording.